Hello, everyone. We are very excited today to share our new prototype or example, and it's gonna be very excited. But let's wait a little bit for people, to get their coffee and to mingle. Uh, okay, so the purpose of this webinar is not to present; it's more to be more interactive. So please use the chat. We will be reading your comments and let us know first from where are you joining, and also what are you more interested in. We're going to cover a lot of ideas and concept from modeling, meshing, analysis. And if you let us know what are you more interested in, then we can tailor our talk more to your interest. And lastly, if you are using any automation tools, please let us know what kind of tools are you using. That will also help us make like a comparison and to give you like an insight. Maybe there is something better, or maybe your tool is better. So let's keep it more interactive and engaging. So I see Judith from Switzerland. Nice to see you. And we also see Yandre. Where are you calling, Yandre? Out of curiosity. So this is the first time the full team is joining on the webinar. Usually we pick one or two, but we decided this time, like all of us, we go on stage so the people can know us more and we can have more interactive discussion. We're gonna introduce ourselves briefly. So I am Muhammad Adil. I am a structural engineer and a software developer. I participated in the design of multiple high-rise building in Qatar, where I designed like canopies, shear walls, and I moved to the Netherlands to do my master. It was in the same field, structural engineering. And I also worked as a structural engineer doing earthquake projects. And maybe around 5 to 6 years ago, I completely shifted to software development for the goal to understand like how to develop proper software, not just a scripting like in Excel and in Python. So I've been joining multiple startups where I join big teams and also small teams to gain the proper knowledge how to develop software. And now I want to bring it back to my beloved passion, which is structural engineering. And this is why we build the platform, so that's we can improve in the way we are doing. Abdurrahman, you can introduce yourself.
So, hi everyone. My name is Abdurrahman Masri, and I'm a BIM software developer, and I'm a part of the Awatif team. That's it.
Great. Maybe you can tell us what is your experience more.
So, I'm
Or
more interested in generally in the open BIM workflows and programming, and also in 3D programming as well.
great. Peter, he is from Egypt and he used Python. Oh, this is the typical one. And so speaking of Python, Kel mentioned he couldn't join us, and he mainly used Python, but we kind of convinced him to shift to JavaScript, and he still used both, and he liked both. But the benefit of JavaScript is it's web-based, so we prefer web-based application because this is where it's easy accessible and it has a lot of benefit. So Kel Manson, he's based in Germany. He works at Arup. He's the only structural engineer who's working full-time in our team. So we gain a lot of knowledge from him on how to design, because he is really practicing it. Sadly, he couldn't join us today, but you can find him in LinkedIn, and he's a very talented guy. Musab, you can introduce yourself as well.
Yeah, hello everyone. I'm Musab. I have a background in structural engineering. I started in Sudan and then I found myself in Sweden. I did a master's in structural engineering and focused on modeling timber structures. I also have a background in data science and artificial intelligence, where I did some work in AI. And now my passion is to combine machine learning with advanced numerical modeling with structural engineering to build uh, automated apps that makes the workflow of structural engineering easy. Yeah.
Great. We have Sergey from North Macedonia. Very interesting. And Ruba Adil from Qatar. Ah, this is where I used to work. Hello, Ruba. Okay, Kaison, you're the last one.
Sounds good. So my name is Kyson. Again, my background is in structural engineering as well. Same with other people on the team. Currently, I'm working as a software developer at a structural engineering company. We focus on high-rise projects. I was actually involved in a couple of design projects. So um, I think my goal and what I've been doing is to apply my design knowledge and structural engineering knowledge in order to help people build better workflow to help improve um, the status quo and build better design workflow, and not just design workflow, and also BIM workflow as well. That's something that I've always been passionate about.
Great, thank you, Kaison. I'm just gonna say hi to Simio from Nigeria, Chris Tillett from South Africa. Sorry if I mispronounce your name. And Yandre from Australia. We are very excited that you are here, guys. And if you have any questions or remarks, feel free to ask them. And yeah, we can always chat. But if we didn't get your question, definitely at the end we have the Q&A session, then we can answer your question. Let's now dive into it. We have a lot to cover, so bear with us. These are the topics we'll be talking about. Let's start with the live demo. I think this is the most interesting part. Then you're gonna have an idea what we are doing. So the good thing about Awatif, it's web-based. So if you just type awatif.co in any browser, even if it's in your phone, you can access our apps. And there are many examples, like you can do curves, whatever, buildings, but we have this slab designer. It's encompass a lot of the ideas and the concept we want to bring. So I'm just gonna go through it a little bit faster than I used to. So this is like a slab supported in columns. And here I'm showing the deflection, like in the Z direction. This is typically one of the first check you do. And the nice thing about this platform, if you change the column location, the analysis is done in real time. Like we're talking here about FEM analysis. This is an accurate result. And you get them instant. The same if you wanna, for example, look at the bending moment of the column. You can see here, like, where are the reinforcements, for example, and if you change the column, you can see how they are changing in real time. This is what we call the manual modeling, because you are using the mouse, but you can also use the parameters. So here I'm changing the mesh size, I can changing the loads. But I think would be more interesting example, which we don't have here. If you have drop panels and you need to change, let's say, from a drop panel system to flat slab, you can actually toggle the system, and it's done automatically through a parametric way. And this is something you can easily do with JavaScript, because you can see here, this is the source code of all of the whole application, and you can extend it the way you want because it's open source. Another thing, you can also look at the normal forces at the columns. in real time. So if you add the column at the middle, you can see how this column affect the other columns, which is something very handy if you're designing a building. And lastly, before I forget, you can also draw a new slab. So here I'm just gonna draw some like a new slab just to see. You can first draw the columns, then draw the slab, and you still get the real-time analysis. One important point, the data, you have full access to it through these tables. So whatever you add here, it will be shown. Let me just clear what I did. So these are the columns. If I add a column here, it's shown here automatically. The same goes for the slab. And you get a report, which is highly customizable. Here we have in like a sample for CLT designing for bending. And if you see the utilization factor here, that gives you the strength of this slab. So actually you can increase it until you reach something below 100, and you know the capacity of your slab. This is done in real time. And you can actually export the report for the reviewer or other parties to do your design. So I can talk about this demo forever, but let's keep it short. Just play with it. It's online here, and let us know what you think. Going back to the slide now. So now I'm going to share with you the story, like why we are doing this. As I told you, I was working in Qatar, and I participated in this high-rise building, and I was designing the penthouse of the owner at the top floors, and the architect prepared all the layouts, and I spent like 2 to 3 weeks designing, the slab, the columns, how everything fit together. And with one day, I think the architect told me, can we change the layout, because the owner wanted to change the layout. And I just realized my 3 weeks of work has gone to waste. This is a typical process in many structural engineering firms. Like the design change most of the time, and you need to redo your work, and this is very inefficient. And I remember after the second iteration, the architect again told me like, oh, can we have a swimming pool? I'm like, seriously? So this is why we need to do something better. And we decided to work on this platform, which we call Awatif. To talk more in depth about what is the problem exactly, our problem, we are using multiple software to do the design. And basically our data is the same. And this data has to be moved between all of these apps, like you do the analysis in ETAP, or you do the design in other software, use Excel for reporting. And this manual process of transferring the data is error prone. And if you do any mistake, that means you need to redesign. And if the design change, that also means you need to invest a lot of time. And this is the bottleneck in general. There are ways to solve this kind of problems, like with Grasshopper or Dynamo, where you can write your geometry in a scripted way that allow you to change instantly, but we still rely on other software to do the analysis, to do the design, and this is very time consuming. And also with Grasshopper or Dynamo or visual programming, the code can become very messy to the level that the owner or the author of the script cannot read his own code if it's get very messy. So it's not a very scalable solution. This is why we decided to use languages like JavaScript, which is script-based, that allow you to abstract your concept in different folder. And we also abstract the need or remove the need to use other software. We can do all of this in one app, similar to the example I showed you. You can do the FEM analysis, the reporting, all in one memory or in one system. And that is very efficient. And that allow you to do optimization where you can run thousands of iterations with these parameters, which is something very difficult if you want to do with the manual process or use Grasshopper. These are heavy processes. And on top of that, it's open source and web-based. And I cannot stress how important these are, but you can just look at what Google Sheet did to Excel, what Figma did to Photoshop, we are following the same trend and try to modernize how we design buildings. Finally, we mainly say Awatif is a parametric modeling, but this is not the only area we're focusing on. There is also optimization algorithm. So we're allowing the engineer to ask question like, what is the most efficient system we can use? Like a lateral system. Then the algorithm can run thousands of iteration and give you the best design. And also fast solver, this is something also we really need, because if the FEM analysis takes some time, weeks, then how are you going to do optimization with this? We're also working on this, and there are some novels idea how to make them fast, which we're going to talk about them maybe in next webinars. That's it. Sorry, it's a lot of talk, but now let's shift to Kaisen so he can tell you more about the modeling aspect. 1 second, let me change the screen.
Yep, sounds good.
Yes, here is yours.
Okay, perfect. Thank you. Moving on to our next section, modeling. So yeah, so Mohammed has mentioned earlier, Awatif is like at Awatif we're a strong believer in the power of parametric modeling. I mean, we can take the Trust Designer as an example. Here we have a fully parameterized app. Nearly every single variable is parameterized. Like for instance, your span, spacing, web type, etc., etc. And you can imagine it would be very convenient whenever there are changes in your design requirements, your layout, etc. And like Mohammed mentioned earlier, it happens very often. So with our slab designer, that's like the first thing that we went after, is to keep this parametric modeling principle in mind. And here we have exposed things like mesh size, load, some other material properties, and the thickness of our slab. And by doing so, it allows us to optimize our structure quickly. It allows designers to scale the design easily per different design scenarios, like for instance, your load changes, etc. And again, say if you want to add a drop panel, a different type of structural system, you will be able to do that through this parametric approach. And coupled with our fast solver, this allows the design to really be reactive. You will be able to get real-time results according to different design parameter value. So that's the power of it. However, we soon realized that there's no one-fit-all solution when it comes to modeling. I think from a user perspective, what users are looking for is flexibility. We want to give people as many options as possible. So here we've embraced a hybrid approach. We want to provide user with a manual way of inputting other parameters. For instance, here you can move your columns around through the graphical interface, and you can also adjust the column coordinates and redefine coordinates in a table format. So by embracing such a hybrid approach, we want to give as much power and authority to users so that they can have full control of their design without having to juggling between some inefficient user interface, which we as designers face day to day in our workflow. So that's all about pro modeling. Moving on to our next section, meshing. So as we were developing Slab Designer, we came across a challenge. It's meshing, and when it comes to meshing, and there are two folds of it. First is how do we represent these models, namely the high-level object and low-level object. I'll explain what high-level and low-level object refer to, and how do we convert between high-level and low-level objects. So in terms of Slab Designer, the high-level object would be a physical model, In this case, would be a single story in your building. And here with the slab designer, we've divided up the single story into the slab component and column component, similar to how you would define your building structure in other BIM software. And doing so, it will allows data interpretability, say if you are working with other software, and that's something that we are trying to achieve as well here at Awativ. So yeah, within Slab Designer, you'll be able to visualize the slab and column like what you see here as well, not just the analytical model. So after that, we have implemented a meshing algorithm that converts your slab and column into shell and frame elements. So this algorithm is robust. It allows you to, like for instance, wherever you place your column, it will be able to merge with the slab as long as the column lies within the slab boundary. Say if you define a new slab, the same thing applies. So this really provides flexibility and really harness the power of a real-time FEM engine and allows you to do analysis quickly and in real time. So yeah, that's all about the modeling part. I'll pass it on to Musab on to analysis.
Yes, thank you, Kaison. And yeah, I'm going to talk a little bit about the analysis. So I'm going to talk about our new shell element formulation, and for its it is based on Reisen and Mendlin shell theory. And I'm not going to bore you up with a lot of math, but I'm just going to give a very high level explanation about it. So each node has 6 degrees of freedom, 3 translations, and 3 rotations. And the powerful thing about this element is that it eliminates a lot of numerical problems, so to say. For example, the shear locking. And more on that, if you are interested, you can read in the paper here that we based our shell modeling, shell element on. And basically, the stiffness matrix, the element stiffness matrix combine 2 parts. One part that is related to the membrane stiffness, and the other part is related to the plate stiffness. So in general, this is a very high level overview of how we develop this new shell element. And as Muhammad showed you in the live demo, that it is very fast, very robust, and it can give you the results in real time. So as you change the loading and the geometry and different parameters, you get real time analysis. So it's really powerful. And yeah, of course, it is very important to validate such modeling techniques. So here we see a simple mesh study. As we increase the element density, the elements density, we see that the numerical solution approaches the analytical solution, and this is in very great accuracy, I would say. And yes, this is all about it. And if you are interested in knowing more about it, please don't hesitate to reach out to me. I can give you some more hints. And yeah, of course, after analysis, it's very important as structural engineers to do the design, right, and the reporting. So as Mohammed showed in the live demo, we have this report, and the analysis first, it is done in real time. As you change the different parameters, the utilization ratio, and all other analysis related properties are changed in real time. And so you don't have to run, analyze, and then wait for the analysis results again. And the same as well, we have the report here. It is fully parameterized, and you can change everything in real time, and you can eventually print it as a PDF. So this is really fast compared to using conventional reporting and design tools, where you would have very long Excel sheets. We all agree that this is boring. So We are trying to eliminate that. So yeah, that's good. And now I give the mic back to Muhammad, where he's gonna talk about integration. Yeah.
Yes, maybe before going to the last section, a quick shout out to Niskin from Hong Kong and Alon from Israel and Seth. Oh, that's going to be a difficult pronunciation. Satyasanilin. Sorry if I didn't pronounce it, from India. It's nice to see you here. And yeah, let's move on with the last session. Musab Misery will tell you more about the integration part in Awatif. Just one moment.
Yeah, so just tell me if you can see my screen.
Yeah.
Okay, great. So after you've seen the power and capabilities of a Watif platform, let's look at how the same engine can be integrated into different environments, giving you interactive and easy to use experiences. So basically, one way to think about a Watif is as an engine at the core. The analysis and visualization don't have to stay in our own interface. It can power a web app or even plug seamlessly into many other environments. So as you can see on this slide, we have a few examples. So Awatif can sit inside a Victor apps to provide instant structural checks, or run directly in Google Sheets, where engineers calculate and visualize results in a shared spreadsheet. The same engine can feed results into Power BI dashboards for reporting and decision making. It could be used to automate through N8N workflows to trigger analysis in the background, and even connect back into Revit or Speckle to enrich BIM workflows. So here we have a small concrete example. We here can see that we connected Awatif to Google Sheets, and our viewer can be plugged directly into the sheet, as you can see. And the cells are used as inputs to run analysis, and we can even write the output results back into the spreadsheet for instant feedback and collaboration. Another good example here, you can see the kind of integrations we can do also. So here is the work done with Victor App Builder. Alejandro Duarte on LinkedIn shared this app. He built an application in Victor that connects directly with Awatif. This is a great showcase of how our engine can integrate into other platforms to extend their capabilities. So basically, the bottom line or the idea is that wherever you're working, Awatif can plug in and give you both the analysis and visualization. Now I'm going to hand it over to Mohammed.
Sorry. Great, guys. Thanks for all the explanation and presentation. And here we are at the last part, which is any question from the crowd. And if you are really interested in learning more about the platform and how it works, just feel free to book a session with me at this link. We can have more elaborative discussion. And I will be the face of the company. So also follow me in LinkedIn to know all the updates and what we are working on. Although the platform is generic, but we have focus on buildings because this is what we are passionately driven to. But we can use the platform to design any kind of structure. It could be a bridge, it could be a canopy, staircase, it could be a whole stadium. But as a team, we're gonna focus on buildings and build a product that we're gonna release, like something similar to ETAB and Safe, which has these kind of capabilities of real-time updates It's open source, it's web based. So there is a lot of work waiting for us. So the stage is open for you guys on the chat. If you have any questions, feel free to ask. I see one question from Judith. Which kind of building project is your software currently best suited for? So 80% of the buildings, sadly, they are using concrete. So we're gonna focus on concrete, trying to optimize, at least reduce the waste that comes with concrete. But the concept is similar. We can always shift to timber or steel. I hope that answered your question. Another question, will the FEM still work with the same pace if the structure is multiple story? Musab, you wanna get this one?
Yeah, in principle, yes. Our FEM solver is very fast and it's optimized for the web. So yeah, feel free to build and test and yeah, if you find any problems, we are always here to fix them as soon as possible. But in principle, yes, it should. The idea or the intention is to have this same performance as we showed in this simple demonstration.
Yeah, so as a comparison, also we benchmark our solver with a native C compiled code. So this is like the fastest thing you can get. And it's actually comparable. It's the same speed because we are using WebAssembly. And WebAssembly is technology that allow us to compile our JavaScript code, sorry, our C++ code into a language that can run on the browser. But if the building is really huge and there is a lot of degree of freedom, maybe we need to run it on a thread or run it on the backend. But for now, it's everything runs smoothly on your client on the browser without the backend. But that's depend on the scale of your building. I hope that answered your question. Let us know if you need more elaboration. Okay, question from Said Nisleen. Sorry, I have missed the first 5 minutes, but should I approach the company for creating a code customized for our company analysts? Yeah, feel free to reach out to me. The best way is to book a session, then we really go into it and get to know each other. So if I want to use it tomorrow, how do I go about doing so? Or do I need to be an expert in programming? Oh, I'm glad you asked this question. Kaison, you want to answer it? Or give me your opinion on this.
Yeah. Well, I can talk about my journey joining Awatin. I started contributing to the platform and creating my own apps 2 years ago with little to no background in JavaScript and the framework that we were using. And my background was actually mostly in Python and C Sharp. And I think from my experience, having some level of understanding in programming in general, it's important in order to navigate the code base. That's certainly useful. Um, However, I think the Powerball a lot of it with so many examples, and the code is easy enough to navigate. And I was working with Mohammed as well, and to get a better understanding of it. But even with myself, I was able to create and implemented a dynamic solver. It was a simple pendulum, double pendulum system, and just a toy to play around with. But then that really got me involved and understood how the platform works. So, there is I wouldn't say there isn't any learning curve, but it's certainly achievable, even like myself, with a person without any, strong background in JavaScript development. So hope that answers the question. Answer the question.
Yeah,
I
thanks.
think it's also worth mentioning that in the near future, we are adding more documentation and more examples. So it's certainly going to help implementing.
Yes, I see also the same question is being asked again. This is something we really realize at the beginning, like not all structural engineers they like programming, and they stay away from it, although the benefit is huge. But we are targeting both. So we're building the platform for people who are comfortable with programming so they can build their own script. But we also have apps that we're gonna build and make it very easy for normal structural engineer to use the app. So we're still in a phase that at the beginning, we just need to make sure the platform is solid and it's scalable. And we reached this level, and now we're gonna build apps similar to the one we showed you, the Slab Designer. So anyone can use the Slab Designer. It's similar to Safe, but it's easier and faster and web-based. So we have something for both. But if you really need to automate your process, then you need to learn how to use the automation tool like scripting. That's something is not avoidable. Okay. Plugging into different aspects like geometric import from Revit. Okay, this is a question for you, Abdurrahman Mazri. He is asking, like, is it possible to use plugins from different aspect? Can we integrate
Yeah,
in?
but I think just a second. So the question is, the previous question was, will it support plugins? I think he's talking about the platform. Like, will it have plugins to import from Revit to the platform? Is this the question?
Maybe I misunderstood. I thought it's if we can use plugin in the platform, not the other way around. But we can answer the both way, right?
Yeah, so it's totally doable if you have if you want to create a custom plugin in Revit and connect it to a Watif, either to a web app or directly inside Revit, like having a web view window inside Revit where you can display or visualize the structure in our viewer and interact directly.
Yes, I hope that answered your question. Maybe we take one or two last one. The software is quite impressive and seems like you guys have done a lot of work to get it into this stage. Does the Slab Designer account for transfer loads at this stage? Can we also design post-tension slab in the current iteration of the Slab Designer? Can I take this one? The Slab Designer, as it is now, we consider it as a prototype or an example. So it's not even the MVP. So the whole goal of it is to demonstrate these new concepts we're talking about, the high level, low level, how you connect the meshing, how you do the meshing in real time, how you run the FEM analysis. So it was more of explanation how the platform works and the possibilities. But we are really now working hard to make a proper implementation with all the cases. Like we're missing that let's say load combination. We're missing like the point load you mentioned about. We only support now this distributed area. But this is something it's easy to be done since the platform is ready. Like the core foundation is ready. It's just a matter of extending. And luckily we are open source, so there are many people that can improve, like help us move faster. So maybe sooner, Yasin, all of these features can be implemented that to properly design a slab. So just follow us and we will keep you updated. Okay, I'm gonna take last question. Can you give us a ready-made packages library by which I can build script? Well, if I understand you correctly, if you go to GitHub, this is our main repo. It's only one repository. And we have all the packages, depends on what you want. If you want the solver, you can just use the solver and integrate it. It's easy integrable into any kind of system. Like even if you are using a different language, you can maybe put it in a server and expose APIs and communicate, or there are multiple ways to communicate through the network. If you're talking about the meshing, we have an algorithm for the meshing. And if you want to talk about the UI, like how to visualize, let's say the color map, the tables, and this bending moment, you can just cherry pick what you like. So it's all under MIT license and it's completely free. Just check it out and you will find something, I'm sure. Okay, one last question, although I say this already a last question. I am a bridge designer and I use sophisticated software. Can you help us to automate with the spreadsheet? Definitely, this is something possible. Like as I mentioned, the slab design is just an example, but the platform can handle any kind of structural engineering task because we are structural engineer, all of us. So, and we also programmer. Okay, I will answer the rest of the question on the chat, but it was really nice talking to you guys. And again, if you have any more questions, reach out to me. I'm very approachable, and let's have fun together improving how we design buildings. See you in next webinar. Bye bye.
See you. Bye.